And you guys know that ultimately with a nice table, you end up with Ka of the weak acid. It's equal to x squared divided by the initial concentration of the acid. And of course, in that equation was that little minus x as well. And when we were calculating the pHs of the weak acids, we pretended that little minus x wasn't there, so that it makes our calculations a little simpler. But I mean, it is there. We're just not using it, and it's not affecting the number. We're okay. What is x? What does that give you? X, yes. Doesn't x give you the concentration of the hydrogen? And that's why when we solve for x, we can take the negative log of that and gives us the POH. Didn't we do that last time? Okay. Some of those looks were like, this isn't what we did. Okay. So what if we had an unknown acid? And we just need to calculate the Ka of a weak acid. That's all we know. We don't know the identity of the acid. Which has a pH equal to 3.92. So let's calculate the Ka of a weak acid, which has a pH of 3.92. Using this information up top that we went over last time, and y'all know how we got that information, do you see what needs to be done?
Yes. Put the 3.92 or pH and then solve for the H.
Yes. If we know that the pH is 3.92, can we not take that and solve for H? Tell me how I do that again.
10 raised to the negative 3.92.
Right. 10 raised to the negative 3.92. Won't that give me the hydrogen ion concentration? Yeah, 1.20 times 10 to the minus 4. Oh. And I omitted some information that you need. I just realized I didn't give you enough information to solve the problem. Pretend that this said, calculate the pH of a 0.28 molar weak acid, because I needed to put that in there, and I just forgot. Okay? I know, it's horrible.
So what happens if you do that on the test?
Hopefully I would catch it before y'all started taking it. And then I'd say, y'all see on that table those last two numbers? Those are supposed to be to the negative 1. Remember that happened on the last test? I try to work it before y'all do, so I catch that stuff. Okay. This, doesn't that give us X?
Yes.
And so we know then X, and now that I've given you the 0.28 molar that you need, you also know the initial concentration, don't you? Yeah, so can't I just plug it in and solve? Can't I say that the Ka is equal to 1.20 times 10 to the minus 4 squared divided by 0.28 minus 1.2 times 10 to the minus 4. Because since I know what X is, I can include it in that equation. And when I calculate that, I get 5.2 times 10 to the minus 8. The pH of a 0.051 molar weak acid is 6.21. Calculate the Ka. I forgot to hit record, but that's okay. Divided by 0.051 minus the 6.17 times 10 to the minus 7. And when I work all that out, 7.5 times 10 to the minus 12. And remember, it is an equilibrium constant, so it's unitless. Is anybody still not getting that? Or do you have a question about any process?